Okay, so we were talking about the data types yesterday, right? Uh, Post we started the DDL commands. Okay, from that DDL we have seen one command create, and post that create command we were looking into the data type. We have covered the string data type yesterday, right? And the next we are going to see today is a numeric data types. So what is a numeric data type we'll be having? That is what we are going to cover. So numeric data type, as the name suggests, this is like all different data types we are having that comes in a number format, right? So all these numeric data types are in a numeric format, like are in a number format we'll be having. Okay, so any data you will be having into the uh, like a digital or in a digits format or in a number format, that all we call as a numeric data type. Okay, so let's say your roll number, your phone number, or maybe your bank account number, your bank account, like amount in your bank account. That means your net balance, withdrawal amount. Okay, so all these are like a numeric data types. Okay, so there are different types of different data types we are having under this numeric, and that we will see one by one. Okay, so this will always be like integers, decimals, money, percentage, quantities. Okay, order count, and also those all are the numeric data types. Okay, so there are different kinds of data type we are having. Okay, exact numeric data types we are having, and then we are having some decimal numeric data type. Okay, so there are in exact numeric data type, these are the different data types we are having. Okay, so in exact we are having bit, tiny int, small int, integer, and big integer. Okay, so what is mean by exact numeric data types? So when we say exact numeric data type, those will store the exact values, and those data types will not allow you to insert the uh, like precise values like in decimals, in points. Okay, it will not allow you to store those values. So these fields, when we are defining any column, any field we are defining with this data type, this will always store a exact values. Okay, so in that first we are having bit. Okay, and if you see the description, it is saying like this is allow you to store the integer value that can be 0, 1, or null. Okay, you know what is meant by 0, what is meant by 1. You don't know about this null. Okay, if you might know as well, but what is null, that also we will talk. So this bit data type is a kind of yes no kind of data type. Okay, active inactive. So whenever you just wanted to store the information about a row, okay, that can simply define as like whether this row is active, this person is active or not. Okay, so that kind of data type, like information you want to store, so you can have this bit data type. So it is like true, yes, active, like that. Okay, so I'll just mention it here.
Could you make the fonts a little larger, please? Thank you.
So, so numeric data types. Okay, in that we are having exact numeric. So these this will store exact values without precision. What does mean by exact? Without precision, or without I will say decimal as well. Okay, so in that first we are saying is bit. So bit is a data type that is used to store the values as 0, 1, or null. Okay, so there is a meaning for 1, or there is a meaning for 0. So 1 is always used to identify the record as a true or yes, or active. Same way 0 is in a reverse. It is like false, no, and inactive. Okay, so just you want to store the value as an indicator. Okay, let's say you are having some 10 rows here. I'll see if I'm having some table. Okay, let's say I'm having this employee table and I have some data like this. Okay, I have some data like this. If you see here is a salaried flag. Okay, so salaried flag is a column. So what does it means? So they are going to store the value inside this column, which will show whether this particular employee is salaried or not. Okay, so what is mean by one? One means yes. Okay, or one means active, one means true. So when I see this particular business entity ID, the person one with this national ID number, this person is salaried person. Okay, when I go to the next or the fourth record with this national ID number employee, okay, its salaried flag is 0. Okay, which means this person is not a salaried or it is inactive person. It is inactive employee. Okay, currently it is not taking any salary. That is what it means. So salaried flag, we can check the data type of that column as well. Salaried flag. See, it is having a flat flag or it is a bit data type. Okay, so bit data type is used to store the values which will show simply the the record indicator. We can use this as a record indicator to identify whether it is false, true, okay, or whether it is active, inactive, whether it is yes, no kind of data type we are storing. Okay, it will allow only these values. Okay, and these are the valid values we are having. Now, what is null? We have created one table yesterday under this 1031. Okay, and while creating the table, we did not mention anything. What we did is we just created the table with the table name. We have given the column name and we have given the data type. Okay, but when we see the structure here, okay, under the object explorer, okay, you would see apart from the data type, there is something we are having in front of data type. Okay, and that is null. So what does it means? Even though we have not created any table with, we have not mentioned this null and all during the uh, table creation, still it is coming for each of the column. Okay, so null is nothing but it is a no value or unknown value or missing data. So what is null? It is no value, or we can say it is unknown value, or it is missing data. Okay, null is not equal to blank. Okay, this is blank. So it is not equal to blank. Blank is a value. Okay, but if we don't have anything, that is a null. Okay, we will see with some data. Okay, it does not means blank, it does not mean zero, or it does not means false. Okay, null it simply means it is having no value. So it can have these three data only inside a column. When a table is defined with these particular columns, with this particular data type, it can hold only these three values, 0, 1, or null. Second, we are having the tiny int. Okay, and the description says it allows the whole numbers from 0 to 255. It will store the it will take the storage of 1 byte to store a single record. Okay, 1 byte it will take. And if you see the range here, it will only allow you to insert a whole numbers from 0 to 255. So if we create a table, so let's say I'm creating a table here. Okay, create table. Mm, Let's say I will create an employee table and I'm creating the table with ID as an tiny. Okay, and then I am creating a name column with a varchar data type 10. And then let's say I'm using the flag here, employee flag, which is a bit data type. Okay, so I'm creating this simple table. Let's say I'll create this under 1031, execute this, and now I will insert the data. Okay, we have not seen the command to insert the data, but I will just show you how to insert. And you will see. So I'm trying to insert the data into this table. Okay, I'm having three columns. So ID, I'm giving the first value ID as a one. Second column name as, let's say, my name I'm giving here. Okay. And third column we are having is employee flag. So I'm giving this as a active. Okay. I have inserted one row, and now I will just see the data from the table. To see the data from the table, we use select command. Okay. Select star from table name. So select is to see the data, to fetch the data. Star means all. Okay. So from the table, I just wanted to see everything. That is what it means. And from is like from which table we are looking the data. So when I run this command, I will see there is one record I was inserted. Now what will happen if I try to insert the record with ID as a 300? Okay. If I try to insert the record with ID as a 300, it will throw some error. It is saying like arithmetic overflow error for data type tiny int. Value is equal to 300. So it is saying like the maximum allowed limit is being overflowed for this data type. Okay, what I'm trying to insert? I'm trying to insert 300. Okay, and in which column we are inserting? In the first column. That is nothing but ID. So in ID, I'm inserting 300 as an ID value. Okay, but what is the data type of this ID?
Tiny,
Tiny integers.
tiny
Right?
integer.
So it is a
Tiny
tiny,
integer.
right? So it is a tiny integer. So what is the range of this? The range is 0 to 250,
255.
255. But what I'm trying to insert, I'm trying to insert 300. So it is going beyond the limit. Okay, so it will not allow you to insert that value. So the value you are inserting into the column that should be like compatible with the data type you are using. Okay, even though if I'm using some -1, whether it will allow? No, because the range is from 0,
0.
0 to 255. So it will not allow you to insert the negative values as well. Okay,
It means
even
number of rows, or what is these to
no, this is the value.
value, not number of rows, right?
No, no.
No,
Okay.
this is the even I am having only one row as of now, right? And I'm trying to insert the second row.
Yeah, yeah.
Right, and second row with the value as a something like 255 to 66. Okay, let's say I'm using 256. 256 is just one number more than the range, right? Because allowable maximum is 255. Still, it is not allowing me to do that because
So
that is again beyond the range.
this table will create just 255 rows only, right?
Yeah, maximum of 255 rows we can insert,
Yeah.
right?
So
It
instead
is
of
not,
integer,
okay, it is not like that also. If you don't want the duplicate into this, okay, only unique rows you want, then only it will be 255,
One duplicate,
256.
it might be more than
Right.
255 rows.
Yeah. If you are inserting the one value multiple times for different employees, you can
Hmm.
insert as many rows, right? There is no limit.
So it is better to have the big integers instead of this one, the
Yeah.
tiny
So that,
integer.
correct. So that depends on for what purpose you are going to use the table. If you know I will not have more than 100 records in my table, you can use the tiny integer there for your data type. Right? If you know your table is much growing, you can go for some other data types.
So this is valid for just one table, right? The 255?
Right. This is only for this table. Whatever table we have created. Okay. And inside that as well, this is only valid for this particular column because the column data type will be like tagged to a particular column. Right. Each column will have a separate data type.
So what is the benefit of this tiny integer instead of that integer only?
Yeah,
In integer,
if your like data is small set of data you are having, I will not be going to have some more records into the table. Okay, so you can go with this kind of data type. It will save the space again because it is taking 1 byte to store a single value. Okay, but if like your record counts will be more than 255, so you cannot use that. You can go with the small integer or big integer as per your requirement.
to save the space. Okay, okay. Got it.
Okay. The second or the next data type we are having is a small integer. So now all these small integer, big integer, these are very similar to the what we have seen as a tiny int. The difference is the range and the space to store the value. Okay. So as you go on to the next data type, it will have some different range. So small integer, it is from minus 32,000 to plus 32,000. Okay. So it will allow you to insert values between this range. Okay. Then integer allow you to insert the values between this range. Again, it is a 10-digit number in integer. 21, 47, 48, 36, 48. This is from negative to positive. So having a huge range. Okay. Even you think like my data is like more than this as well. So you can go for the big integer. Again, it is having a range more than the integer. Okay, but it will take the 8 bytes data to store a single value. Okay, so data type we can choose as per our requirement. Now let's say how we will decide the data type of these columns. Okay, what should be the data type? How we will be deciding? Anyone having any Google form? Right. Yeah, we don't have. Okay, sometimes what will happen? You will go to the website, any website you will go. Let's say I'm going to this Zorba portal. Okay, I'm going to this Zorba portal, and I want to store the information. Okay, about this page. Okay, so whatever the page we are having on the Zorba portal, I want to store all this information. I want to create the table. So whoever the users are like here, who are like registering to this Zorba portal, I want to store all this information. Okay, why it is not opening? Okay, it is open. So all the registered users information I need to store. So I know there are columns we are having. Okay, so each of these you will be putting the data here. Okay, you will be putting the data here. Let's say you are having some name here. Okay, you are having last name, you are having gender. Okay, like this you are choosing here name and all. Okay, so based on the column or based on the description of the column, you should be able to choose the data type. Right. Now I'm having this personal information data here. I'm having first name, last name, gender, email, and then contact number. So you know like what kind of data should be inserted into these fields. Okay. We are having education and experience. You know what kind of data should be here, right? So highest degree. So it is having a string data. Major we are having, like in which major you are taken the degree, passing year. We know it is always a integer data, right? It cannot be a string data. Experience, whether we will have the experience in string, Okay, it will be always a number like 2 years, 5 years, 10 years, 20 years, right? It will be always a number. Then university, it is a string data, right? Then when we go to the address, we'll be having this street address, apartment floor. This all will be a string data only. So based on your need, you need to choose a data type. Okay, that is all a developer's responsibility to select a specific data type for a column. Okay, and how you will choose based on your application. Okay, so these are all exact integer data type we are having. Next we are having is a decimal. So decimal and numeric, these are the two data types we are having which are used to store the uh, precise values. Okay, not the exact numeric. It will be used to store the precise values. That means we'll be having the point values here. We'll be having the decimal values. If you want to store that, okay, you know, account balance. We cannot store the rounded value there, right? Bank will always store the each and every decimal point there, right? Because they have to maintain the data accuracy, right? Even the withdrawal amount, like, or we can say deposit amount, transaction amount, total balance, they always maintain a accurate amount in decimals. Okay, so such kind of columns should have this data type, right? Such kinds of columns should have these data types. Okay, where like anywhere else we use this? What can someone give an example for these decimal data types or numeric data types where we store the values in a precise format?
Like grade, student
Right.
grades,
Grade, marks, percentage.
percentage.
Temperature.
Right. So we know you want to store percentage, right? So yeah, so these are the applications we'll be having where we use the uh, precise values in decimal points. So first we are having this a decimal, and after decimal we are having something like P and S. So what is P and S? P is for precision and S is for scale number. Okay, and it is having the range as well. It will allow you to 10 is to 30, 38, it will allow. Okay, plus 1 minus 1. So range is very huge. Okay, and the data type, I'll just go here once again. So data type is decimal and it is mentioned like P and S. So what is this P and S? P is for precision. Okay, which is nothing but the total digits we are going to store. Okay, that I will say that can be stored. Okay, so P is for total digits that can be stored. And then second we are having S. S is for scale. Scale is nothing but digits after decimal point. Okay, so the digits after decimal point. Let's say in this particular table, I will add one more column as a salary. Okay, and I'm mentioning this as a decimal and I'm saying this as a 5-2. Okay, so when I say 5-2, what does it mean by? So 5 is a total digits. Okay, and 2 is digits post decimal. Okay, so what kind of values I can insert here? I can insert the values like 100.20. So here, what is this? These are the total number of digits, and 2 we are having. 2 is for digits post decimal. If I go to store something like this, okay, 50, Whether it will allow me to do that?
No,
No.
No, because
it
it's
is
only
different.
allowed like
Yeah,
5
total.
digits.
That one
Right.
is different.
Right. So
Yes,
total
yes.
digits is exceeding. Okay. Let's see. To do this, I will just drop and recreate the table, or I can simply add this column using alter command. Okay. We have not seen that. We will see under table employee. Right. I'm adding one more column to this table. It is added successfully. You could see now the salary is there. Okay. And now I will try to insert the record here with true. Okay. And I will give some name here, that different name here I'm giving. And salary I'm giving this as a, I'll take same example, 100.20. Okay. The record is inserted and we can see the data here, 100.20. Okay, now let's see, try to insert another record. Okay, with some different name again. It is, let's say, 0. And I'm trying to insert here the same value what we discussed here. Okay, now see here, we are trying to insert the value and it will be throwing the error showing like arithmetic overflow error converting the numeric to data type integer. Okay, so what it is trying to do now, it is trying to insert the 6-digit value. The total number of digits is 6. Okay, but how many we are having? We are having the range is 5, right? So it will throw the error. As soon as I remove this one here, it will successfully insert the data. And we can see here. Okay, so this numeric or the decimal data type will allow you to insert the precise value. What will happen if I'm not giving the values post a decimal? If I want to store only the values like this, 5555 and 5. Okay, something like this. So 3, 3. So I'm giving a 6-digit value here. Okay, if I try to insert, again, it will fail, right? Because 6-digit is not allowable. What if I'm just giving a 5-digit value? That will also not allow. So what if I'm giving the value like just a 4-digit value and trying to insert? Same thing happen, but as soon as I give the 3-digit value, okay, you see here, even though it is 4-digit value, it is not allowing to insert. Why it is not allowing to insert? Because the data type is a decimal, and when we try to insert the decimal values, by default it will try to insert the values like this if we are not giving the uh, values post a decimal point. Okay, so by default it will try to insert 00, and when it is trying to insert 00, in total it will have the 6 digits. Okay, that's the reason when we are giving the 4-digit value, it is still not allowing you to insert the values. When I try to insert 3-digit value, it will allow me to insert, and we can see along with the 3-digit value, it has inserted the precise value as well, 0.00. Okay, so like this, or like in this way, it will always store the values inside a column. Okay.
Okay.
Okay, so this is what the decimal data type is. And next we are having a numeric data type. Okay, so there is no difference between numeric and decimal. We'll be having the exact same thing there as well. We're having P and S, precision value, and the scale we are having. Okay, so both are like same definition we'll be having. The range is also same. Okay, the size they are taking, though, that is also being same only. Okay, so there is no difference between those two data types. Okay, Apart from this listed numeric data type, there are some other data types also we are having. Okay, that are not listed out in that particular table, but we have that. Okay, we are having money data type. So that is used for currency value. Okay, and that will store the data into the decimal format only, P and S. That's the reason it is not mentioned separately as a data type. But yeah, we can define the column with money as a data type as well. Okay, money is a data type. Then what else we are having? We are having small money. Small money as well we are having. So this is for smaller currency range, we can say. Okay, then what else we are having apart from these two data types? Money, small money, it will take always double the volume of, half the volume of this data type to store the data. Let's say, so if it is taking 8 bytes, it will take 4 bytes to store the values. Okay,
What is
then we
currency
are
range?
having some approx numeric data type. Okay, approx numeric. So in that we are having float. Float is a data type. This is uh, used for large decimal values. Okay, for example, if you want to see, if you want to store the value of pi, we know like pi value, right? Something 3.14, right?
1.14.
So yeah, 3.14. But if you go in like very precise, it will be having some number like 141592653 something like this, right? And it will goes on increasing, even though you are if you go more deeper, right, it will be not the actually 3.4, it is having a multiple decimals point after that. So if you want to store all the values, all the range, you can use this float data types. This is used for scientific or large decimal values. I will just mention that word as well, scientific or large decimal values. Then we are having real as well. Real is a data type. This is for smaller version of these scientific values. So we can say smaller floating point numbers. Okay, so smaller version of this. So we can have temperature, right? So temperature sensor, we can have float data type. Then what else we can have? Here to store these pi values and all. Okay, so these all are the data types we are having. Okay. Yeah, and these all are the numeric data types we are having. So next we are having, see, data type, you need to understand the concept here. Okay, you know different data types we are having, but where to use this data type, why to use that particular data type, that is important. Okay, so data type will be tagged to a particular column within the table. Okay, and how we are defining that column, that is important. So if you want to store some value, like let's say you have been assigned to create a table. Okay, so you need to choose what should be the columns. Let's say I'm saying I'm giving you the question to create a table, okay, for storing the employee information. So what kind of employee information we can have, right? We can have employee ID, we can have name, okay, we can have joining date, okay, we can have salary, okay, we can have employee flag, that will decide whether it is active or inactive employee. Okay, if it is inactive, we may have the last working date. Okay, last working date. Then we can have the email of the employee. Okay, so multiple things we can have there. Okay, so these are all you need to think. Like when I say you can you create an employee table, you should know what are all the columns can be there in that employee table. That level of thinking we need to improve. Okay, when we have decided to work as a developer, our thinking level should be increased. Okay, everything we need to think. No one will be giving you all the details. Okay, your manager will just say, hey, just create this table. Okay, so what kind of columns we'll be having? Even though if you give the column names, he will not say what is the data type. Okay, you have to choose the data type, appropriate data type uh, based on the assumption of what kind of data it will be having. Okay. Yeah, the next data type we are having is a date data type, date and time data type. Okay, so here we are having multiple data types here. Okay, all are like again the date format data type. So first one is a date time. Okay, so the date time data type is store the values from the range January 1, 1753 to December 31st, 1999. Okay, along with the milliseconds accuracy. Okay, so it will allow you to store the value up to millisecond accuracy. So it is not always have only the date, it will have the time part as well, but within the time part as well it will be having the accuracy up to the seconds. Okay, so there is one SQL function we are having which will show you the current date. Okay, and that function is a get date. So get date is a function that is used to show the current date and time. So when I run this command, it will show me the current date and time. So it is, if you see here as well, we will see it is 5:22, 2026, 7:37 is now, it is 7:37. But when I run this, it was 7:36, 55 seconds. And the milliseconds as well, it is showing 327 milliseconds. That is why it is saying it will show you the 3.33 milliseconds. Okay, the date time data type. So this get date function will always show you the data into the date time format, which means up to milliseconds accuracy. Okay, the second we are having is a date time 2. Okay, so any column we have defined with this date time as a data type, we will not be able to store the value beyond this limit. Okay, and before this limit. We cannot store the date which is 31st of December 1752. We cannot store the date which is 1st of January 10,000. Okay, we cannot store that. We can store the values up to this year 999. Okay, 9999 actually. Yeah. Okay, same for the date time 2. The range is changed for starting point. Okay, so now here we were able to store the value from 1753 year, but here we are able to store the value from first year. Okay, the to limit is same, but the change in accuracy here, it is showing the result up to the 100 nanoseconds. Okay, now we will see how it will show up to 100 nanoseconds. So same thing I will take and I will run this as date time 2. So you will see I'm having the both results. Okay, I just need to cast this. Now you will see, okay, here is one result, which is a simple date time data type. Okay, but second, I was converted this date time data type to date time 2. And when I convert this date time 2, it will show some higher precision, right? It will show some higher precision. Now it is 00, that's why it is showing. Now let's say I'm taking this 487 and this I'm taking again date time 2, it will show some more precise values, 446 and all. So the accuracy will be increased. So if you want to store more accurate data like launcher, the rocket launcher details we are having. Okay, so such kinds of scientific values you have to store where the accuracy matters, even the nanoseconds accuracy. So such information will be stored in this date time 2 format. Okay, whether the birth date or joining date, whether those all kinds of information need to store with this much accuracy?
No.
No, right? It is not needed. So based on your need, you need to choose what kind of data type should be chosen for a particular column. Okay. Then next we're having small date time. So here uh, it will be used for small date and time. Now the range is also limited. It will be used up to 2079 only. Okay. And starting point also it will be only from the 19th century. Okay. And accuracy also it changed. It will show you the accuracy up to 1 minute. So it will not show you the milliseconds data. It will show only the data up to seconds. Let me just change this to small date time. Okay, so you see here, it is not showing you the second data. That means the accuracy is only up to how many times, no matter how many times I will be executing, it will not show you the seconds data. That means it will always show the second as a 00. Rounded of minute value it will show. That is the accuracy we are having for the small date time. Next, a date. As the name is here, we will not have any time part for this data type. It will be only used for storing the date values like joining date, birth date, like resignation date, right? Uh, what we say, registered registration date, right? So only the date is needed, not the time part. Then we can go with this data type. Okay, so when I run this get date function that which will show you the today's date with only the date data type, it will show you only the date part and not a time part. Okay, same way we are having a data type called time as well, which will show you only the time part and not the date part. Okay, only the time part up to milliseconds. Okay, then we have this date time offset. So date time offset. Now this is something which is very rarely used. Okay, date time offset. So date time offset is a again date and time data type we are having, which will store the date, time, even it will store the fractional second, and it will show it will store the time zone offset as well. So what is time zone offset? We know there are multiple zones across the world, right?
Mhm.
And this data type, timestamp, sorry, date time offset will store the difference between the time zones. Okay, and it will calculate the difference from the UTC. Okay, coordinated universal time. Okay, it will calculate the difference between that uh, particular time zone and with respect to the UTC time. Okay, so it will store the data like in this format. Okay, always it will be YYY MM DD. Okay, then it will have HH MM seconds. Okay, and then it will have some difference. How much hours of difference we are having between the given date from the UTC time. Like this, it will store the data. We'll see some value. Okay, so let's say I will be selecting the same as date time offset. Now I'm running this query in Indian Standard Time in IST, right? And when I run this, it will show me the IST time only, but along with the IST time, it will show me the difference between the IST and UTC. Okay, so okay, it is not showing the difference between the offset. It is not showing. It is showing the current time, but it is offset is showing 00. Ideally, it should be like 5 hours more than the UTC time. Why it is not showing that? Whether we need to mention the time offset command something. Let me choose some different way. Select sys date time offset. This is system date time offset. Now it is showing. Yeah. So you see here, it is a function which is used to get the system date time offset. So current system time and offset from the UTC. So it is showing like this particular time is 5 hours ahead of the UTC time.
Mhm.
Okay. So why this kind of data type is needed? Okay, it is not again, as I mentioned, very rarely used, but why we used to have that? Okay, so let's say we are having some table where we are having the user's login detail, and India user login at 10 a.m. IST, and let's say US user login at 10 a.m. EST. Okay, so when I use the normal date time, it will store the particular date whenever he logins. It may be in a IST or it may be in a EST. It will store that value, but it will not let you know the information between the difference between the login hours. Okay, so if you have this date time offset along with the date and time, it will store the difference between the UTC time and uh, that particular zone as well. Okay, time zone. So it will be easier. So some of the information we are preserving there so that we can use that for the future calculations or decisions, something like that. Okay, that's the only use case we are having here. Just it will store additional data along with the offset between the UTC time and the current time zone. Okay. Yeah, so these are all the different data types we are having under the date time, date and
Sir,
time data types.
sir, quick question.
Yes,
Yeah, here in date time, what is the January 1, 1753? Before that, we cannot store the data.
right. We
Date.
cannot store the data before this January 1, 1753. Okay, so let's say we will go with this example again. I will add some column here called joining date. Okay, and I'm giving this as a date time. Okay, so how to add this column using alter command I will do. I'm adding one column here called joining date. Okay, so if you see the data now, you will see the data with joining date. Okay, and let me try to insert one more record here. The record number 4, and name is Santhya, and active employee. This is the salary, and joining date is, I'm trying to insert the joining date as a 01/01/1753. Okay, so 1753 I'm trying to insert here. It will allow me to insert because this is a minimum range we are having. Like from this date we can insert the data. But what if I'm trying to insert the record beyond or before this? Okay, let's say I'm having some other name here. Let's say Raj, and then we're having active employees. I'll change some salary, and I'm giving the name as a year as a 52. Okay, and 31st 12. That means one day prior to the above record. Okay, okay, it should be like in MMYY format. So this will be 12, 31st. So yeah, DD, MMDD. Okay, so when I run this, it is showing like it is out of range value.
I think it's
Okay,
salary.
no, it is not a salary, right? It is 500. So 500 is fine
It's
because
1752. That's why it's not, I think.
it is 1752, right?
It should be 53.
Right. So from 53, from 1st January 53, we can insert the record up to 31st of December 1999. Okay. Before this limit and after this limit, we cannot insert the data because our data type is date time data type. And date time will allow you to insert the date range from this date to this date only.
Okay.
Okay. Yeah, so these are all the different data types we are having under the SQL Server. So this all we'll be using for our tables. Okay, whenever we will be creating a table, the data type is mandatory. We need to provide the data type for the column. Okay, and what data type we need to provide? We need to provide the data type any one from this list, like date time, string, or a numeric data type. Based on your need, you will choose the data type there.
Once again, will you please elaborate date time offset once again?
Which one?
Date time offset.
Okay, date time offset. So date time offset we are having. Date time offset, what is the date time offset? So date time offset is a one of the data type we are having, which will show you the date and time. Okay, date and time data along with the time zone offset. So what is time zone offset? So
Time
time
zone
zone offset
difference.
is the difference
In a
between the
query,
time zone. Okay, difference between the time zone from the zone from where you are running the query and the UTC time. So it will always take UTC as a standard, or we can say the median time. Okay, and it will calculate the difference from UTC to your time zone.
okay,
Okay,
got it.
the IST,
So why
like
it is in a UTC? Why it is in a UTC? It doesn't have the CST or some other time zone? So always is there used by UTC only time zone or a different time?
yes, difference it will calculate always from the UTC.
Because it's
No, like
universal.
Yeah, there is a standard time, like it is the median time zone we are having, right? All the differences will calculate from the UTC only.
It's a
So,
baseline.
right, it is a baseline.
Because UTC does not change with the season, like in Eastern time, it changes with every
Yeah.
time. That's why universal time is used so that it does not change in any time of the year.
Right. It is a universal coordinated time throughout the year,
Mm-hmm.
it will be the same. Okay. Okay, so now let's create one table with all these data types, including, okay, most of the data type I will say. Okay, let's say I want to store the major we will see. Okay, not all, but the mostly used data types we'll be having, right? Those we will see, and we will create one sample table. Okay, for example, let's say I want to create an employee table. Once again, I will go with this create table employee. What is the syntax for creating a table? Create table, name of the table, open bracket, column name, data type, column name, data type, right? And it should be comma separated. So let's say I'm inserting employee ID. So employee ID can be integer. Okay, there can be more than like 1,000 employees as well. So we can go with the integer. Then we are having this employee name. Let's say it is storing the full name. So we can have some varchar 255 or something as a data type, because we don't know what number of characters a name can have. It can have 100 as well, or sometimes 10 as well. Okay, so varchar 100 to 255 we can take. Even email as well, we can go with the same thing. Can store the email in a varchar format. Okay. Then let's say we are having a mobile number. Can we go the mobile number with integer data type?
I think
Yes.
I think we cannot go with integer data type for the mobile number. Okay, even for Indian mobiles, okay, it will always start with 70 or maybe 999, maybe 9896 something, and it will be a 10-digit number. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so it will be a 10-digit number and it will start with 9093 something 99. So that is out of range because 10-digit number integer will allow, but it will have the range of 2147 something. If you are happy with 9, that means it is more than this. So majority of the time we will not be able to store the mobile number into the integer data type. Okay.
We can use tiny integer.
No, how we can be using tiny integer? Because it will be up to 255 only.
Big integer.
Yeah, either we can go with a big integer, okay, or you can go with a varchar itself, right? Because in a varchar also we can store the integer value. Okay, see the difference here is in varchar data type you can store the integer values, but in integer you cannot store the varchar values. Okay, we will see this during insertion of the data. Okay, this is an important thing to understand or to remember. In integer data type we cannot insert the string values, varchar values, but in varchar data type we can insert the numerical data. Okay, keep in mind. Then we are having age.
Question. If
Yes,
the employee ID is also like 10-digit long and if it starts with like 9 or 8, we can put
right.
in that.
We can go with a varchar or we can go with a big integer,
Okay, thank you.
right? We cannot go with the integer in that case. Okay, then age. What should be the data types of age? Whether it will be a integer or big integer, what should be the?
Integer.
Integer.
We can go with a small integer or tiny integer as well, because I don't believe like we will be having the age greater than 255,
Yeah.
Okay.
right? And
Mhm.
even age cannot be negative as well,
Yeah.
right? So 0 to 255 should be the good range for the for the age column, right?
Mhm.
Yeah.
It will not allow you to negative as well as it will not allow you to the insert the more than 255 values as well, which is again a very bigger for the age calculation. Okay, these are very huge we are having, even though it is allowing you to negative, insert the negative. We don't think like negative is needed for the age, right? So age should be like tiny integer. Then we have the city. Let's say we are using the city. Again, we can go with varchar here,
Okay.
right? Varchar 50 something. Then we are having joining date. Okay, it can be a simple date data type, not necessary to store the
Daytime.
time value for that, right?
Mm-hmm.
Why can't we write varchar in everything just to save the storage?
Right. That is important, right? Because storage is important to have for our database. So everything cannot be just a varchar, right? That's why we are having different kinds of data type. If everything should be same, we should why Microsoft will like invent all these data types, right? So there is some advantages of using different data types as per the requirement. It will save the space. Again, it will faster your queries. Okay, when we go or when we are moving forward, we will be saving different things there. Okay, the indexes, the constructs. So it will all fasten your results. Okay,
Mm-hmm.
can you go on mute? Yes,
Wash it.
okay, so it will help you to faster your queries. to run your databases smoothly. So we are having these different kinds of data type. Okay, let's say I want to use the login time. We know for the login time, minutes are also important, seconds are also important, right? So we cannot just go with the date here. We can have either date time or date time too, which will give you the more accuracy up to the seconds. Okay. Then let's say we are having the flag for checking the employee is active or not. We can go with is active, and it is a bit data type. Okay. Yeah, I think that should be fine. These many columns as of now. Okay, so like this, we can have a different data types for each of the column within the table. And as per our need, we can define those. Okay, so mostly I will say integer data types are used for IDs. Okay, IDs or let's say counts we are having, we will use this. Okay, varchar we will use mostly for names, emails, okay, text values, we will use this mostly. Then the tiny int we'll use for small integer values. Like age. Okay, then we have the decimal. Decimal we'll use for the salary, okay, or money related information, money calculations we can just say. Okay, then we are having date, which is used to store only the date values like DOB. We are having joining date, join date, and so on. Okay. Yeah, so these are all the mostly used data types we are having, which we can use for our tables. Okay, as per our need. Okay. So next we will move to the next SQL command. Okay, so this is all required for DDL and while creating the database. So we moved back from the create to see the different data types. Okay, so yesterday we have seen the create command. Create is used to create the new database or new database objects, like creating new database, creating new table, creating new procedure, creating new view. And what is the syntax? So syntax is like create object. Object is nothing but whatever object we are creating, that you need to specify there. If you are creating table, you need to specify create table. If you are creating a procedure, you need to mention create procedure. If you are creating a table, you need to specify create sorry, if you are creating a database, you need to specify create database. And after specifying the object, you need to give the name to the object. Okay, like if you are creating table, table name should be there. If you are creating procedure, procedure name should be there. If you are creating database, database name should be there. Okay, and after this database name, the syntax is different for every single object. So table, as of now, we are just going with the table. So for creating a table, you need to specify create, then table keyword and name of the table, then open bracket, close bracket. Within these brackets, we need to specify the columns along with the data type, and each column should be a comma separated. You need to specify there. Okay, we have seen, and we are having the example here as well. So create table, employee, open bracket, employee ID, integer, employee name, integer, varchar. Okay, now the question is whether we have to have the queries written like this only. We call these entire things as a query. Okay, whether we need to have like this only. Okay, what if I will have this written in this way? Okay, I'm having this employee and I'm having a bracket here itself. Okay, I'm having the employee ID and we are having only one space. Second column also in the same line. Okay, third column also in the same line. Okay, it will not throw any error. It will also create a table. We are having three columns into the first row, next columns or to the next row. Whether it will show any error? No, it will also create the table. Okay, then why we are writing the queries in this way? Okay, so this is the practice I wanted to have from the day one from all of you. Okay, to make your code more readable. Okay, it should be easy to read. It should be more. It should be look good. Okay, it should not be like complex. It should not be like a complicated thing. Okay, we should be able to read the code very easily. Okay, and that's the reason we are following some standards here. Okay, even though if I'm writing the everything into the one line, it will also create the table without any issue. Okay, but we should be writing the queries, okay, in a more readable format so that uh, we will not be confused on the, okay, it should be when we look to the code, it should be quickly identified what is it in, okay, what we are having there in the code. Everything should be more clear. Okay. Yeah, so this is the syntax for creating a table. Let me create this table by selecting this and executing this. Okay, so it will create a table under the 1031 database. Now we are not seeing that table, but when I refresh this, I will see that table here. Okay, the employee table is there. Okay, if I want to see all of these columns, how I can see? If you expand the tables, the particular table, you will see there are multiple columns, multiple folders, like column folder, keys folder, constraint folder, triggers, index. All these are different things we can create on a table. Okay, we will be seeing those later words, but currently we are worried about these columns. So if you expand the table and within that table there is a folder called columns. If you expand that folder, you will see all the columns that has been created by you while creating the table. So all these columns along with the data type will be visible here. Okay, employee ID, employee name, email, mobile number, and all. Okay, as it is, you will be able to see these columns here. Along with this column, we are having this null thing here. What is that null? It is an empty value. That means if you are not inserting anything into these columns, it will allow you to insert the record. Okay, the empty, or we can say the no value record. Okay, that is what this null means. Now let's say I have created this table and I was missed to add the field for the salary. Okay, which I wanted to store the salary of that employee 10 to. I was missed to add this. Now I have added this, and if I try to recreate this table, what will happen?
Throw the error.
It will throw the error because we are trying to recreate the table with the same name. Okay, so what will happen? It will throw the error like the table employee or the object is already exist. Okay, the object named employee in the database is already there. Okay, so how to do this? Now the table is there, but I want to add the new column. Okay, so how to do this? So for that, we are having the second command in the DDL, which is alter. Okay, alter by the name itself, it is alteration of the existing thing. Okay, so what we are doing here in the using alter command, it is used to alter the structure of the database. So the database is already there, the table is already there. I want to modify the structure. Okay, again, we are dealing with the structure. We are not mentioning anything about the data inside the table. Everything is related to structure, like the column addition. Okay, we are not saying data addition. We are saying column addition. We need to add one column. There are some 10 columns. We need to add one more column. Okay, there is one more column. There are 10 columns. I need to delete some column. Okay, so we are dealing with the modification or creation of the structure itself, not the data. Yeah. So what we are saying is we were just considering the structure of the database as of now. Okay, we are not dealing with the data. So alter is used to alter the structure of the database. This change could be either to modify the characteristics of an existing attribute or probably add a new attribute. That means it is saying we can add a new attribute, which is nothing but either new column, okay, or new code we can add, or we can modify the existing as well. Okay, what is mean by modifying existing? Now let's say we have this city column mentioned as a varchar 50. Okay, and I found like there is one city which is having more than 50 characters. So I wanted to modify the data type of this city column. So what we are doing here, we are modifying the existing attributes, existing characteristics. Okay, and this is adding new attributes or adding new columns, new characteristics. Okay, so all these we can do using alter command. This command is used to modify the structure of existing database objects like table, procedure, function. So not only table, we can alter the procedure, we can alter the function, we can alter the trigger, view, anything. Okay, so there are different commands. So this is the one to add the new column. Okay, so to add the new column in the table. So this is the command. Alter table. We need to specify the table name, which table you are altering. Okay, which table you are going to alter. Then you need to specify add keyword, add, and then the new column name. So which column you are going to add, that column name you need to specify. Okay, and then definition of the column, which is nothing but the data type of the column. Okay, so with this our example, I will go alter table. What is the name of the table? Table name is employee. Now add keyword, then column name. What is the column name? Salary. And the column definition is nothing but the data type of that column, salary. So with this particular command, I will add the salary column to the employee table. Okay, let's execute this and see whether it will reflect. Okay, it is added, it is completed successfully. You could see the columns here. We don't see the column salary. Let's refresh this and you will see there is a column added for salary.
And what can we do to remove that column? We can use remove.
Right. So to remove anything, again, removing in the sense what we are doing, we are again changing the structure of the table, right? Any one column we are removing. So what we are doing, we are modifying the structure, right? So we need to use the same alter command only, but we cannot use the add keyword here. Okay, we have to use the drop keyword. Along with the drop, we need to specify the column, drop column. Okay, and now when we are dropping the column, we don't need to give the data type. Okay, because the data type is for definition, for defining it. Now I am not defining, I just wanted to remove that. So the standardized syntax I will mention here. Alter table, table name.
Can you use truncate instead of drop or not?
Drop column, no. We have not seen what is truncate, so I'll let you know, but we cannot use that. Okay. So this is for
Is it same?
dropping
I
the
just want to know, is it same drop, delete, and truncate are same or
no?
no? Okay.
No. Okay. To remove the column or to delete the column. Okay, we use this command.
One more thing.
Okay. Yes.
So when you are writing like table underscore name, can we do like table name continuously without having any space?
This is just a standard syntax. Okay, this is not a table name. I'm just mentioning here we should have the table name.
So
this
we
is
can
the
do
standard way. Okay, this is a standard way. We should have the table name. If your table is having the space, okay, if your table name is having space, you can add have that table name as it is. But when we are having space, the table name should be in a square brackets.
Bracket, but like we can continuously write it, right? Employee info without any space.
Whatever your table name is, right?
Okay.
If your table name is like this, you can write like this. If your table name is like this, you should have written like this. If your table name is having underscore, it should be your underscore. Okay, so whatever the table name you are having, that name you have to write it down here.
Sir,
Okay.
we
Yes.
can alter table name as well, not columns, table name.
So you want to modify the table name.
Yeah.
Okay, so to modify the table name as well as the column name as well, there is some different thing we are having in SQL Server. Okay, we cannot use the alter command there for renaming the object. Okay, I will talk about that later because that is something like advanced thing we are having. Okay, but as of now, I will show you one graphical way to do that. Okay, you can do that from the Object Explorer by right clicking here and click on rename.
Oh.
Okay, you can do that from here, the table name and even the column name as well. Let's say you want to have this column name renamed with just an emp name, not the employee name, emp name. Okay, just you need to rename. Okay, and click outside of that, it will be changed.
Oh.
Okay, so this is a graphical way using Object Explorer. You can do that. Okay, to use the to do that with a query way, there is some different syntax we are having. We'll be talking that later on. Okay, during the stored procedures. Okay, but if you want to rename as of now, you can go with this Object Explorer and you can do that in a graphical way. Okay.
Thank you.
So with this, you can add the new column, you can drop the new column. Okay. Similarly, there are things we are having like constraints. Okay. So you can add the constraints as well. So constraints can be added during table creation, or if it is missed to add during table creation, you can add the constraint later on using alter command. So what is constraint and all you have not seen, so I'm not going in deep, but we can add the constraints as well. Even we can modify the stored procedures, right? With the alter command, we can modify the functions, we can modify the views, any other database object we can modify. Okay. So this is the alter command, which is used to add the new columns, or which is used to remove the existing column, delete the existing columns from the table. Okay. Next two commands we are having in this DDL, the drop and truncate. Okay, that we will talk about it tomorrow. Okay, we still have some time, so I will show you the same things like creating a table and modifying the table structure using graphical way. This we did using writing a query. Okay, this we did using writing a query. What if I wanted to create a table using this Object Explorer? You can do that as well. Okay, so what you need to do, you need to expand the database, go to the tables folder, right click there, and it will have the option to new. Okay, so new table. So when I click new and table, it will give some window to create a new table. Okay, where we can give the column names. Let's say I'm giving the column name as a student ID. Let's say I want to create a student table. Okay, student ID. What should we create a type? I'm giving this small integer. Okay, then I'm giving the column name as a name, and I'm choosing the data type as varchar something, varchar 50. Okay, I'm choosing the name as an email, and again I'm choosing this as a varchar 50. Okay, so let's say I'm just creating a column with a table with 3 columns. Now the table I have defined, but it is not saved into the database as of now. So how to save that? You need to right click here on this top. You will have the option to save. Okay, so right click here and option to save table 1. Now here you can give the name to the table while saving students. Click
Where do
OK.
we have to click?
At the top here, the pin icon you will be there, right? So there you can right click. you will be have the option to save that. Currently I have saved it, so I'm the option is disabled
Okay.
now.
Okay.
And you
Okay.
can see now the table is created with name as a students.
Okay.
Okay. Now using the same graphical method, you want to add some column to the table. Okay. Now the table is there. If I want to add the column, I can go with alter table command. Okay. Or if you want to do that using graphical method, so here also we have that option. You can go to the column, you can add the new column. Okay.
Okay.
When you click on new, it will open the same window where you can add the column here, like let's say DOB, and I'm giving this as a date data type. Okay, date data type. And now just right click and save students because we made the change. So right click and save the table. So we'll add the new field to the table. Refresh it, you will see that.
Okay.
You want to modify the existing. I want to change the data type from varchar 50 to varchar 20. You can do the same thing as well here. Okay. So everything that we can we can do using create and alter using the query method, we can do using the graphical method as well. Okay. Even if just right click on the table name, you will have the option to modify or design. Okay. So when you click on design, it will open the same window with the column name and data type, where you can add the columns, where we can simply remove the columns here. Okay, delete column. Okay, we can do that as well. Okay, so yeah, we can do this graphical method as well, but this is just for information. We like in real time, we will not go with this graphical because there will be many more columns we'll be having in a table, maybe 1,000 and all. Okay, sorry, hundreds and 50 columns we'll be having. So it will be difficult to go with this graphical method. It will take much longer time. When you are expert in writing the queries, you will be more faster than writing doing that in a graphical method. Okay, so you have to do the practice using writing the queries only, because in interviews as well, you will not be asked to how to do that using graphical method. They will ask you to write the queries. Okay,